step back from that edge, my friend. We could cut ties with all the lies that you've been living in. And if you do not want to see me again, I would understand. I would understand. I would understand. Hello everybody, welcome to this week's edition of Video Notes for Mr. Flugum's General Chemistry class. That's right folks, this is for Gen Chem. And just so you know, these notes will go on page number 52 in your notebook. Thanks for tuning in, you guys. Let's go ahead and get started. Alright folks, so we're going to be looking at chemical reactions, like this one right here. In fact, this is the example that we'll spend most of our time on. Right, we've got some hydrochloric acid mixed with some salt, with some zinc. We're going to get zinc chloride and some hydrogen gas. Now the way this breaks down is this. When we look at an overall picture of a chemical reaction, we have two parts to it. We have the reactants, right? That's what goes into the reaction, okay? And we have the products, right? The products are what is on the right-hand side of the arrow. That's what you get out of the reaction. Okay, now let's start looking a little bit more in detail at this chemical reaction. One of the things that's in it is what's called coefficients, right? So you can see here, coefficients are the large numbers that are in front of the substances, okay? Now in this particular reaction, we only have one coefficient. However, in some reactions you can have 3, 4, or many different coefficients, right? Now what these do is they multiply the number of particles. Okay, so this 2 here multiplies the H and the Cl, okay, so that it tells us there's 2 H atoms and 2 Cl atoms involved in the reaction. Alright, now continuing on and looking at some other parts, we have these little indicators down here. What these are is their states of matter, right? The S, of course, is solid, and although we don't have it in this one, we have liquids, right? G is for gas. And the one that's kind of weird is this one right here, AQ, which is aqueous. And you can see that in two different instances here. That means that the substance is dissolved in water. Alright, just a quick note here on this arrow, right? The arrow is the yield sign. So sometimes we think of it as an equal sign, but it's really not. What it's really indicating is what the reactants make or yield when you put them together under certain conditions. Alright, so that's what the arrow means. Okay, last but not least, let's talk about these guys. You should be familiar with them. We use them a lot when we're writing chemical formulas. They're called subscripts, right? They're subscripts because they're written below, right, the general line that we write all the other letters on. Okay, they indicate the number of atoms in a compound, right, of a specific atom. For example, right here, right, we have 2 Cl atoms in zinc chloride. Here we have 2 hydrogen atoms in a hydrogen molecule, right? Now, here's kind of the deal with these, and I want to try and be really clear about this. Once you write them correctly, you can't change them, okay? We're going to talk about balancing chemical equations. That's kind of the first thing we're going to address when we come back to class. What we need to understand is this, is once we get these subscripts correct, once we find out oxidation states and all of that stuff, we need to leave them alone, okay? And there are other methods for balancing the chemical formula. Alright, to wrap this up, I want to talk about this, the law of conservation of mass. And hopefully as I talk about this will clear up some of the maybe questions that came up as I talked about subscripts on the last slide. Okay? So, law of conservation of mass says this, right? You can't create or destroy matter. However, it can change forms and be rearranged, right? So the implication is this, and when I say implication, that means what does this mean when we talk about chemical reactions? Well, basically it means this, right? The amount of matter that you have on one side of a chemical equation has to be equal to the amount of matter on the other side, down to the atom. Okay? We can't change identity of atoms, and the atoms themselves have to be the same number. So if we check out this equation, right, if we look, this coefficient says, hey, I've got two H's, right? Well, do I have two H's on the other side? I do. I have the two with the coefficient 2 times Cl. I have two Cl atoms. Do I have two Cl's on the other side? I do. Okay. I have one zinc atom and I have one zinc atom. I am good. This is a chemical equation that follows the law of conservation of mass. So what we're going to look at when you come to class on Friday or Thursday is we are going to look at, hey, how do we balance these equations when they don't match the law of conservation of mass? Well, thanks for tuning in, you guys. I appreciate your time and your effort, and I will see you in class on Thursday or Friday. Bye-bye.